Hey everybody, good to see you back again. I wanted to take some time to make a video about the intake and exhaust manifold system from the 1929 Caterpillar 10. If you've been keeping up with the channel, you know I've been slowly getting that put back together, finding a lot of extra things to fix along the way, and these were no exception. I got to looking on the other day, found quite a few things that needed to be corrected, a lot of problems with them, so long story short, the whole system is completely apart on the bench. Pretty much everything's been gone through. So now is a good time as any to talk about not only the design and function of these pieces, but to show you what all I had to do to them to get everything working properly again. So this is the complete manifold system from the Caterpillar 10, loosely assembled, so you can get an idea how all this is laid out. It consists of three main pieces: the exhaust manifold here, the intake manifold here, and then this is what I call the heat riser assembly. This is what the exhaust stack would attach to. And these pieces were designed to work in conjunction with one another to allow the operators to burn some of the lesser refined tractor fuels of the day that didn't quite have the volatility of gasoline. And the way this would work is, if you're burning like a lesser grade fuel, you have all the hot exhaust gases coming out of the exhaust manifold, and they enter the heat riser here, where there's a butterfly valve inside that's attached to this shaft. Now the operator can adjust this butterfly valve to direct the hot exhaust gases, if he so chooses, from the manifold, from the exhaust manifold, down into the intake manifold, where it goes into this area here, which is actually a heating jacket that surrounds the intake manifold runners, where that incoming air and fuel mixture would be flowing into the engine. Being able to circulate that hot exhaust gas around that runner would preheat those lesser grade fuels, help them vaporize more completely, and then they could be more easily burned inside the engine. So once that exhaust gas would circulate around the intake runner, it could come up the other side of the butterfly valve and then exit out the pipe. And conversely, if you were just burning straight gasoline and you did not need to preheat that mixture, the operator could also just close that valve again, at which point it would bypass this intake system completely and just come out of the exhaust manifold and straight out the stack. So now I will get into some of the reasons why I felt it was necessary to take all this stuff apart and explain a couple of the repairs that I did. First one, I noticed the core plugs that are on each end of the intake manifold here that seal that heating jacket had a lot of soot coming out, like they were leaking exhaust, and sure enough, I found that they were rusted very thin, had some pinholes, and you can see they pretty much completely caved in when I went to drive them out. So, but long story short, in order to gain access to those areas to work on those plugs, I had to separate the exhaust from the intake manifold. That wasn't too big of a deal. I was able to get the nut off over here just fine. I got the nut off this side too, but it gave me some problems because the stud had corroded all the way out to this outer flange of the ear here, and was sticking pretty badly. So in order to save the cast iron, I ended up sacrificing the stud. I had to drill the center of it out and then blow it out with a torch. But once I got that material out from the through hole right here, then both pieces came apart quite nicely. And that, in turn, gave me plenty of access to get new plugs put in there. These are just 1-inch diameter core plugs, really nothing special about them. Once I got those replaced, the next thing I had to do was drill out and extract the rest of that stud, which luckily I was able to do. Saved all the original threads and was able to get a new stud to go in there as a replacement. So that was pretty much all I had to do to the intake manifold. So I then moved on to the heat riser assembly, namely this heat circulation valve, the butterfly valve here. The issue I had with it was that it had not been moved from the position that it was in probably for decades, and it was stuck in the full heat circulation mode. I really didn't like that because I only ever burned gasoline in this tractor, and I really didn't need to be preheating the intake manifold quite to that extent. I was afraid it may even be detrimental to the engine, so I decided as long as I had it apart, at least as far apart as it was, I was going to try and get in here and free that up. Like I said, I was unable to make any of this stuff move, so it was pretty much necessary to take both of the end plates off and then try and get the entire valve and shaft assembly out. In order to accomplish that task, again, I had to sacrifice the steel shaft in order to save the pieces of cast iron. What I ended up having to do was drill out the center of that shaft where it goes through the bores in these two side plates. What that did was remove enough interior material to reduce the amount of pressure that was being exerted by the rust and corrosion on this shaft inside of that bore, and it loosened it up enough that I was able to get these pieces knocked apart. And as you would expect, all 4 of the bolts that secured these end plates to the heat riser assembly broke off when I tried to remove them, but luckily I was able to get those drilled out and saved all the original threads, extracted all the broken pieces, so I got pretty lucky there, and I saved both of the end plates and didn't crack or break anything. At that point, I was able to get the original butterfly valve out. Like I said earlier, I had to sacrifice the original steel shaft. I was able to reuse the butterfly plate. That seemed to be in very good condition yet. Nothing special about this shaft. It's just 1/2 inch diameter shaft, 5.5 inches long. The butterfly valve was just kind of held on by 2 peened over 1/8 inch diameter steel pins, and with a 1/4 inch hole in the end for the coupling that attaches it to the heat control lever and shaft where that comes through from the dash. So to give you an inside view of how this heat control system works, now that it's all operating correctly, separate the 2 manifolds from one another. I have the heat control butterfly valve in the full heat circulation position right now. So the way this would work, hot exhaust gas comes from the engine through the exhaust manifold and is directed into the heat riser chamber, where it is directed off the front side of this butterfly valve to exit through this front opening and down into the corresponding front opening of the heating jacket on the intake manifold. That hot exhaust swirls around the intake runner, exits on the other side of the center baffle out of this rear port, goes into this corresponding rear port of the heat riser, at which point it is directed by the back side of the butterfly valve straight up and out the exhaust stack. So if you did not need any kind of heat circulation, the operator could manipulate the heat control lever on the dash to change the position of the butterfly valve. So this is the full cold position where you're not getting any heat circulated through your intake. So the way this operates, the exhaust gas comes from the engine through the exhaust manifold, and it enters the heat riser through this upper port right here and is blocked by the butterfly valve from circulating down into the intake and just goes straight up and out your exhaust pipe. Pretty simple system, really, and that's basically how it works. Now to reassemble all these pieces. This part's pretty self-explanatory. Put the butterfly valve inside the heat riser. Got both the end plates installed with new bolts and lock washers, and I went down to one of my parts machines and sourced 4 of the authentic C-marked Caterpillar bolts found on machines of this vintage. I just like keeping everything all quite matching that way. Now to join the intake manifold to the exhaust system. Fortunately, my gasket surfaces were in pretty decent shape. I just had to take a little bit of time, make sure they were clean and flat. All in all, plenty of material left there. Got my new gasket in place to go between the 2 assemblies. Got that from Olson's Gaskets. You can look them up online, olsonsgaskets.com. Not trying to do a commercial here, but they sell some pretty good stuff and have some gaskets for some pretty obsolete applications. So let's get both of these placed together and throw the new hardware on there. And I'm just going to leave them loose for now because I want to be able to slide these 2 pieces in relation to one another in order to make sure that all of these ports on the front are all in line with each other. So what I'm going to do to get these lined up is just kind of leave this just kind of finger tight, rather loose the way it is. Bolt it all up to the engine block. I'll let the gasket surface on the engine block act as my straight edge, at which time I'll tighten those 2 nuts and make this assembly secure. So I'm just going to slide it on the studs, and we're not worrying about a gasket to go between the manifold and the engine for now, because this is not a permanent install. It's just going to be temporary. But I'll get some nuts and washers on here. We'll get enough of a clamp load on it to align everything flush with the face of that engine block. Alright, got all 4 of the main attachment points secure, and everything looks like it's lined up really well at the engine. So what I'm going to start doing, if I get the proper wrench in my hand here, is to start tightening down on the new hardware between the intake manifold and the exhaust system. And I'm going to start compressing this new gasket a bit. And I think what I'm going to do is periodically loosen all 4 of these main attachment points and then tighten them again to take into account for any discrepancy, any travel I might have between these 2 pieces with the crush of that gasket as it all gets tightened down. So I got the manifolds tightened to one another. Everything went really well. Everything seemed to be well equalized, so there's no excess bind or tension on anything. And again, for demonstration purposes with this whole heat control valve, you guys are probably sick of it by now, but I just quick mocked up the control rod with the control lever from the dash, and that's where you see this cold and hot. Of course, cold is that non-heat circulation mode that flapper valve is in, where the exhaust is just exiting straight out the pipe. And if you so choose, you can move the lever down to the hot position, and that in turn moves that flapper valve correspondingly to give you all your heat circulation through the intake, and then it goes out the pipe. And you've got plenty of notches in between. You can have it positioned too. So about the last thing I can do right here is to give this thing a new exhaust pipe. This is just 1.25 inch heavy wall pipe with 1.25 inch pipe thread down there to go into the manifold. Nothing too complicated about that. So it's a few days later now, and I've applied a pretty thick coat of a brush-on matte silver heat-resistant paint. This should very closely resemble the type of silver high-heat coating that would have been applied to these manifolds at the Caterpillar factory when they were new in 1929. So with that, I have a fully functioning manifold system for the Cat 10 once again, and I can resume the reassembly process on that. So guys, as always, I thank you for watching. Like and subscribe. If you have any questions, comments, feel free to leave them down below. I'll try to get to them all. In the meantime, hope to see you back again.